idea. Now let us start how to create the part modeling of nut. Now this is the important calculation, so first read thoroughly this calculation and then read the profile of the nut. This not creating any confusion, only just to see. But now let us start how to create the part model for nut. Define the unit millimeter, define the name of the part, okay. Now define the destination folder where you actually want to save this part file. Okay, now we are in graphical user interface of NX. Here you have to define the plane. And kindly switch to open in a sketch task environment, which is a dedicated sketch application. Draw the freehand sketching or freehand profile of nut as given in your drawing sheet. Here sketch is not constrained, so first we will apply all the necessary dimensions as given in your drawing sheet. Kindly apply only those dimensions which are available in the drawing sheet. One by one. And kindly mount the dimensions in very correct way. Assign collinear constraint to the baseline which follow the x-axis of the coordinate system, and these two lines are also collinear. Once you click the geometrical constraint or dimensional constraint, then you will come to know which curve is moving, so that you can assign the necessary definition whatever required. Now the sketch is fully constrained, but the dimension of the sketch is not in accordance of what given in our sketch. So first we have to make our sketch fully constrained irrespective of the dimension values. Now let us say this is fully constrained. Okay, now use delay evaluation. It will freeze the current situation of the sketch and define all the values given in your drawing sheet one by one. Okay, the value for this portion is actually 40 minus 6, that is 34 mm. if you follow the previous slide, then you will understand the calculation for internal diameter and the size of this square profile. At the starting of this video, I have calculated the values and now I am using all those values to create this part. So it is very necessary for us to read the drawing carefully so that you will understand in case of whole base system what we have to refer, and in case of shaft base system what we have to select. Okay, now let us see. As I have clicked the delay evaluation, the drawings shrink to, or we can say fit to, the values given by you. Now this is the correct profile of cup, sorry, not cup, this is part. This is the cut section. Now we can create the internal thread for nut. So for internal thread, first we have to create a path called helix. The diameter for the helix is same, that is 34 mm, and the pitch is 6 mm. By default, if you will use 40 mm, then you cannot able to see the profile because it will get inserted inside the body. So as per my previous calculation, the value for the internal diameter of nut is 34 mm. So here I will provide same diameter to the helix. Change the value from 40 to 34. And please don't apply is equal to, simply 40 minus 6, enter. Now the diameter of the helix is 34 mm. Now here we have to create one profile, that is a square, and that square is going to follow this helix as their path. So first we have to create one datum plane at the end point of helix. And choose the vector for direction. Do not choose curve for the direction, otherwise it will rotate or twist the square. Let's see here, this is the correct way actually. Select and define the origin at the end point of the helix where you have already created the datum plane. Now here at this origin point we have to draw one square, and here we can use the geometrical constraint as well as make symmetric option in order to provide the square property to this quadrilateral. Both lengths are same. Just change the value. Pitch is 6, but the thickness of the thread is 3 mm, so the square is also of 3 mm. You can refer my one PPT I have means attached with this one, means while starting of this video I have done some calculation. From there you can take up reference. Now let's see. Now here we can use an option called sweep. That is swept option. In sweep let's see what will happen if you will choose some different options to create the internal thread. Actually this is not the genuine command for this type of operations, so we have to choose swept option instead of sweep along guide and other sweep options. Actually there are many options to create this one, but here the more preferable is swept. And kindly be assured about the direction. Direction is parallel to the height of the helix, and here we can use connected curves so that we can connect each and every curve of the square. Let's see, this is known as twisting or dancing of square over the path helix. Now with the vector direction, okay, now both the objects are solid, so we can use subtract option. One is tool and another and one is my target. The common portion between tool and target is going to remove. Now this is the nut, which consists of all the specifications given in the drawing sheet. Okay, here we have to create one blend. Instead of using 3 face defining faces, we can use directly edge blend, because if you will use this command, this is not going to create because of some error. So this is also not the right command, so directly use the edge blend and select both the edges one by one and kindly assign 5 mm of radius to each edges. And now this is the complete part modeling of nut. This is the cut section which is available in your drawing sheet. That's it, my dear friends. We will meet in next video. Thank you.